Pre-calculus section 8.2, we are working with logarithms. The directions here: rewrite each expression as a rational number or a single logarithm of the same base. So this is called condensing. Using the product property, since we have two logs with the same base, we can rewrite this as one logarithm with the same base, and we can multiply the two arguments together. Now, what this argument is just simply simplifying fractions being multiplied by a constant. We can divide 6 by 3, it goes 2 times. So this is the same as log base 2 of 16. 2 to what exponent is 16? Well, that would be 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. Let's check out number 2. Now, number 2, you would like to use the quotient property, which says if you are subtracting two logs with the same base, you divide the arguments. We cannot do that in this problem because of these coefficients. Those coefficients cannot be there if we're going to use the quotient property or the product property. So what could we possibly do? If we use the power property, we can take and we can write those coefficients as exponents for the arguments. So this could be log base 3 of x to the 1/3 minus log base 3 of y squared. Now we could write this as one logarithm and use the power property to make this x to the 1/3 divided by y squared. We fulfilled the directions, which were write this as a rational number, which we can't, or as a single logarithm with the same base, which we did. Number 3, notice we can't solve any of these because there's no equation, there's no equal sign, so we're just simplifying. So we can do some things with this. Notice how each of these are logarithms, each term, and they have the same base of e. Notice also there's no coefficient in front of any of these, so we can go directly into the product property and quotient property. We can write these 3 logarithms as one logarithm, and anything that we are adding, we're going to write on the top of the fraction being multiplied. Anything we're subtracting, we're going to write the argument in the denominator. So we could take multiple steps to do this. I'm going to do this in one step, and then if I need to do it in smaller steps, give me a holla. So if we're adding, we multiply the arguments. So that's x times x plus 2. If we're subtracting, we're dividing by the argument. Now this can be simplified a bit because we can divide x into itself. It goes one time, and x into x squared. It's going to go x squared times. So this simplifies to natural log of x plus 2 over x squared. If you want to do this in multiple steps, you could take the first two and say, well, we're adding those so we can multiply the arguments. And then you could say, well, now I have 2 logarithms and I'm subtracting. So the positive one goes on top and the negative argument goes on the bottom. It's not a negative argument, the negative terms argument goes on the bottom. That puts us in the same situation we were there. Number 4, can't use the product or quotient properties if we have a coefficient. So this 2 we're going to write as an exponent for the 3. So it's going to be log base 3 of x plus log base 3 of 3 squared minus log base 3 of y. Now I could interject something else here, and I could have done it before I actually did that. I would have been looking more closely at it. This here is just 2. The reason that this is just 2, well, I tell you what, I can do that, but I don't want to because the directions say that I want to write it as a single logarithm. So I'm not going to do that, but I could if the direction said something different. The reason this is just 2, this is one of the log identities. If you have a base of 3 and the argument has the same base, this whole thing just becomes the exponent of 2. But I'm not going to do that because the direction said write it as a single logarithm. So 3 squared is 9, so I could write this as log base 3 of 9 minus log base 3 of y, and at the beginning I still have my log base 3 of x. I can write this as 1 log of base 3. Any logarithm that has addition in front of it, we are going to multiply those arguments. Any logarithm that has a subtraction in front of it, we are going to be dividing by that argument. So this is log base 3 of 9x divided by y. Number 5. Once again, we want these coefficients to be exponents. We don't always want that, but we do if we're trying to condense into one logarithm. And from there, we can write this as, these are common logs of log of x cubed times x squared divided by x to the 1/2. These ones are on top because they are positive logs. This argument's on the bottom because it's a minus log. Now, using our exponent properties, if you're multiplying with the same base, you add the exponents. If you're dividing with the same base, you subtract the exponents. So this is equivalent to common log of x 3 plus 2 minus 1/2, which is going to be common log of x to the 5th minus 1/2. And if you want to get common denominators, that would be 10 over 5 minus 1/2. Sorry, that's not right. It would be 10 over 2 minus 1/2. That would be 9 over 2. So this would be common log of x to the 9/2. Handwriting is especially not good today. There we go. Make sure your log is one word, not several. Number 6, no coefficient. No, we got a coefficient. So this is natural log of the argument x minus 3 plus natural log of the argument 2x minus natural log of x cubed. I want to write it as one natural log. So I could write it as natural log of 2x times x minus 3 divided by x cubed. I can cancel an x from the top and the bottom. It's going to give me natural log of 2 times the difference of x and 3 over x squared. I could distribute the 2 if I wanted. I don't want to, so I'll just stop there. Number 7, I mean, it's the same thing as the other ones. I'm going to move the coefficient to be an exponent on both the first and second terms. The last term doesn't have one. I write this as one logarithm. If it's addition, that argument goes on top. If it's subtraction, that argument goes on the bottom. If you have multiple subtractions, you have multiple arguments on the bottom. Nothing simplifies. We could leave our answer like so. That concludes the second video, which was essentially condensing several logarithms into one. That's video 2 of 4. We got 2 more for this section. Yay!